Alright, so this is the tough question that I was talking about. It is slightly tougher than the previous question, but I will explain it in a very, very easy way for you guys to be able to solve this differentiation question. Alright, so let's differentiate the following with respect to x. Y equals to 3 over square root x plus 4 cosine cube to the bracket x minus 1. Oops, sorry about that. Alright, so we know that this is like as I said earlier, it can be chain, it can be polynomial. This is a polynomial. Alright, it is not a chain as it has no binomial. Alright, but I just didn't write polynomial, so I'll write it out for you guys here that this is a polynomial. Why polynomial? I will explain it shortly. Alright, but first of all, I will always identify where my x is beside the trigo function. So where is it? Here. This is your aka x. And before I go deep into the question, alright, let me share with you some steps to do trigonometry differentiation. And yeah, I will share, and I will even post the picture on my website. Alright, so the first strategy, there are usually two steps which how I will do my trigo differentiation. Alright, first step is to always look out for where your x is. For the general x. General x beside trigo function. Oh. So the trigo functions that I mean here can be like sine, cosine, tangent. Alright, so like what I write here, my aka x, that is what I mean by looking out for it. And second thing to note when doing trigo differentiation, and in all differentiation questions, make sure that it is the nice way to differentiate. And how do you know if it's in a nice way to differentiate? You need to use a bit of your indices. Like let's say if there's square root x, convert it into x to the power of half, and then like let's say if we have maybe like let me think, x to the power of, like let's say like this, right? Change to x to the power of 2 over 3. It is the same thing. Alright, so sometimes you will need to use little bit of your indices to solve these kinds of questions. Alright, so usually it's involving your indices, and also indices. And then what do I mean by differentiating it in a nice way? It just means that no fractions. Alright, so these are the two things, and the one in orange applies to all differentiation questions, but in trigo differentiation, just at the first step, which is in purple. Alright, so let's move on to the question. Yeah, so as you can see earlier here, I have done step 1. Alright, so step 2, to make sure that if it's in a nice form to differentiate, let's dig into the question. So not yet, so y equals to, you see this term here, nice or not nice? Not nice, right? So what do we know here? Step by step, let's break it down. Alright, so we do know that square root x is the same as x to the power of half. So actually I will change it to 3 over x to the power of half plus 4 cosine cube bracket x minus 1. Okay, but is it in a nice form to differentiate? Again, no, right? Because of this thing here that's affecting us. Alright, so if we know that x to the power of half is at the denominator, so like always remember this indices rule here, x to the power of -1 is the same as 1 over x. And you do notice that I'll write in a different color for the 1 is to make it clear for you. 1 here, invisible 1 here. So now you see 3 over x to the power of half. Let's apply the same indices rule here. This will be 3x to the power of -half, isn't it? And you notice the 1 here, there's an invisible 1 over here, right? Okay, so now I will just change my 3 over x to the power of half to be 3 to the power of 3x to the power of negative half. Alright, so once again, ladies and gentlemen, I will change this thing here. I don't want this anymore. Alright, so now I will change it to, actually, you know what? I will leave it there so that you guys are clear. And I'll write another line which says that y equals to 3x to the power of negative half plus 4 cosine cube bracket x minus 1. Is this clearer and is this nicer to differentiate? Yes. Alright, so from here now, we will, oh, let me write the rule in so you guys won't be confused. So x to the power of, oh, why is it like that? Okay, so x to the power of negative 1, which is 1 over x. Alright. Alright, so let's start to differentiate then. Since it's in a nice form to differentiate, so dy over dx. So this will be equals to what? This is your basic trigo differentiation. And we have two terms. This term, this term. Alright. So purple will be, I'm going to do purple for the first term and green for the second term. Alright. So dy over dx. What would this be? This will be your basic differentiation where your power come down and your power number minus 1. So minus half, oh, minus half bracket 3x to the power of minus half minus 1. Let's see, yeah. This will be minus 3 over 2. Okay. And then this will be now your plus. Alright, so you will add a plus sign. Just copy and paste, remember? And then, actually, should I bring this step down? Right, okay. So, plus what? So what do you add? You add your second term, which is a trigo differentiation. Alright, forgot to write this down. So this is basic. This is trigo. Basic trigo to be exact. Alright. So actually, I'll write all this in blue so that you can see clearer the colors, you know, the different colors. Alright, so this will be okay. So trigo differentiation, remember? Power number bring down, so 4 times 3 will be 12. Alright, and then power number minus 1, 3 minus 1, which is 2, and then x minus 1. Alright, and when you differentiate cosine square x minus 1, ladies and gentlemen, do you write this? I'm going to give you 2 options. Alright, actually 3 options. Purple, orange, or red. Ladies and gentlemen, what do you think? Alright, between purple, orange, and red, which one is it? Answer is the orange one. Alright, remember, red is incorrect. Okay, because there's the power number here, which I've said in trigo differentiation, we ignore powers. Alright, and why purple is wrong? Because of the negative sign. Because when you differentiate cosine, you get minus sign. Alright, so in this case, alright, we will have to, let's see, yeah. Okay, so now let's see what we have here with us, and let's start to differentiate. Minus sign bracket x minus 1. This is just, now we differentiate the inside bracket. So sorry about it, a bit brain dead, but it's alright. I'm back on track. So we differentiate this bracket here. What do we get? We get a 1. And honestly, this one, as I said earlier, or in my previous videos when I do differentiation, when I see 1, I won't write lah. Okay, because x minus 1, when you differentiate x is just 1, right? So it's redundant to write, but I'll write it out for you guys to see here. Okay, so now what do we know so far? Alright, so we can say that this will be let me see, this can be your, you can leave your answer in many ways, but I'm trying to think of some ways on how can I present my answer. I'll present my answer in a few ways, so this can be your minus 3 over 2x to the power of 3 over 3, oh my goodness me. And then can be a minus 12 cosine square x minus 1, and then your sine x minus 1. Or you can leave your answer like that. It can be your which is in green, it can be your you still need a negative here, let's see, 3 over 2, so 2 square like this, x cube. Actually not really, write the square root first, x cube. Alright, so you can leave your answer like this, and then you can write the plus 12 cosine squared minus, or one more way, which I'll write it in blue, actually red, this will be your you can flip the order of how you write it. So I will explain what does all what I wrote, the 3 answers mean, and what do I want to present, how I want to present my answer. Alright, so we look at this, purple, green, red. What is the difference? Alright, purple is, I just copy and paste this one. So this one, negative half times 3 is minus 3 over 2x to the power of 3 over 2. This one, because you notice that this one here, your power is negative. When I bring it to the denominator, it's positive. And then for this one, what did I do here? I bring my negative over here, and I write a minus 12 cosine squared x minus 1, and then my sign becomes positive. Alright, and in this question here, the one in green, what did I do? I changed this x to the power of 3 over 2 to minus 3 over 2 square root x cubed. And then I write the plus sign here, just copy and paste. I write plus 12 cosine squared bracket x minus 1 minus sine to the power of x minus 1. Actually, this one, if you write it like this, which I'll write it in pink, okay, there's one more way to write your answer actually. So you can write it as you can write your answer like this. What did I do here? I just changed this x cubed to x to the power of 3 over 2. And then I just copy and paste the rest. So it's a 12 cosine squared x minus 1 and minus sine bracket x minus 1. After that, it will be a, just copy and paste, just that this x cubed change to x to the power of 3 over 2. And what I do for the red one here, I just change the order of my sine and my cosine. So these two, this one come here, this one go here. So minus 3 over 2 x to the power of 3 over 2 minus sine to the power of x minus 1 plus 12 cosine squared bracket x minus 1. So if you ask me, how would I want to leave my answer? Like which way should I leave my answer in, right? I will leave my answer in the pink color way, if not the purple color way. I will not leave it in the green way because you need to change your x 3 over 2 to the square root x cube. Alright, so if you ask me, the pink, purple and red ways are the best ways you can live in. It is good enough already. But if you want to be even better, you can use the green way, which honestly I don't want to, because I'm a person, okay, I get an answer good enough. I leave my answer properly, okay already. So I will leave it in purple and red. And maybe pink. But for me, I will leave it in pink. Because you see, I can just copy and paste. So see, plus 12 cosine squared x minus 1, I just copy. And minus sine bracket x minus 1, I just copy. I just expand my half into the 3x to the power of negative 3 over 2. And then I get 3 over 2x to the power of 3 over 2. So I will recommend you guys to either write in the pink way or the purple way. But the purple way, you need to understand that because you shift your negative in front, therefore your sine x becomes positive. Alright, so with that, we have come to the end of this second differentiation exemplar question on polynomial, and we will go into another question which will involve chain rule again, and it will be the last exemplar question that we'll be doing for today. Alright, thank you. And yeah, I know it's gonna be about 17 minutes to be exact. It's 16 minutes and 44 seconds on the clock. So yeah, go and take a rest first. If you need some water, go get some water. You want to watch the next video another time, go ahead. Yeah, and I'll see you in the next one.